for another show, for another 30 minutes. I know I always worried about presenting right after Bob because he sets the bar so high. So please don't compare me with Bob. I'm not Bob, I'm Kal. Kal Yella, so I go by Kal Yella. I'm a principal program manager with Microsoft. Been with Microsoft for the last 19 years. No, again, I know there may be some folks who are like about the same age as my experience. Don't raise any hands. All right, so before I start, I know how to start. Yeah. Raise your hand if you don't recognize at least one of the icons here. Y'all can leave my room. Y'all can leave my room. No, I'm just kidding. Anyway, so yes, thank God that not many people raise their hands. But yeah, so this is the SQL, starting from you just heard from Bob about SQL, SQLDB, operational SQL data sources. So Microsoft SQL Server. Anyone recognize that funny-looking icon? Do we have a pointer here? Maybe not. Anyone recognize these things?
Oh yeah.
What's that?
That's 5. Red one's 2008.
2008? Okay. And there's also, we used one of those for parallel data warehouse, PDW. And then the Synapse, you see the Synapse logo there. And then of course SQLDB. So what we are going to talk about for the next 27 minutes or so is about Fabric Data Warehouse, which is the T-SQL Analytics on Azure, which is built upon the legacy of SQL platform, right? So starting from SQL Server, going into parallel data warehouse, going into Synapse. Now we got into an era of AI with Fabric SQL Warehouse. So we are going to talk about that. So you already saw this slide so many times, so I'm not going to bore you with this. But the point, focus on the data warehouse. So Fabric is a unified data platform system based on Copilot integration, OneLake, and Purview for governance. So data warehouse is one of the services in Fabric ecosystem that takes the advantage of all the Fabric functionality and Fabric, the SaaS platform, software as a service, which uses OneLake for their storage, AI for integration, Copilot for AI, and then Purview for governance and security, right? So let's look at a little bit. Can I close this way? I know that phone is muted, but why is it not? Yeah, looks like I cannot remove that. But I'll read out. So Fabric Data Warehouse Engine. That's what it says on top. Sorry, I'm not able to close that for some reason. So let's look into what is inside the Fabric Data Warehouse Engine. So you heard Bob talking about the SQL database in Fabric, right? The operational version of getting the operational data store with mirroring into analytics as well. But this is a true analytics engine in Fabric, integrated and built into Fabric ecosystem called Fabric Warehouse. So for those of you who are familiar with Synapse, raise your hand if you are familiar or used Synapse. Okay, so you may think that this is like a wrapper on Synapse. It is not, right? So it uses the advantage of Synapse. It uses the caching, the dedicated pool mechanism, but it comes with the same engine, MPP engine, massively parallel processing, right? So this is for analytics. You cannot have just one server or like SQL Server. You need a massive parallel processing, and this is the engine that provides that MPP engine with an infinite serverless compute. So obviously for the MPP engine, you need servers, you need nodes, you need compute power. So the compute is provided with infinite, being able to scale and being resilient. I'll talk more about how that happens behind the scenes. But so you can, when you're submitting your queries based on your query requirements, based on the query compute estimation, we automatically scale, we allocate number of nodes needed so your queries can execute fast successfully. So that is the serverless compute. And it's all backed by the open storage format of Delta Parquet. So how many of you know Delta Parquet? Delta or Parquet? Yes, so Parquet format. It's a columnar storage format that gives you the advantage of the performance that you can get from a table, like a traditional table structure. But on top of that, Delta gives you the transactional logging capabilities that are lacking with Parquet, right? Being able to roll back, time travel, all that is provided by the transaction log with the Parquet, so which is what is called Delta. So the data for this data warehouse is backed by that open source Delta storage format, which is well known across the field, right? Like I said, fully serverless and on-demand compute. You don't need to, like for those of you who just raised your hands about Synapse, where you had to pre-allocate, right? So you had to set up the compute and use the compute, and then you pause manually when you're not used. This is on-demand serverless compute. So the compute will be allocated within milliseconds of your query, initiating a query. So the compute will be, it doesn't have to be stored or reserved for your workloads, right? Simple to use with integrated Power BI. So Power BI, I'm sure everybody knows, right? Yeah, so it's integrated, being a part of the Fabric ecosystem. So it's fully integrated with Power BI and data science for, your Spark workloads. Like you can actually connect from a Spark notebook into a warehouse to do some analytics as well, if you would like to do so. T-SQL language support. So because it's SQL backend, Transact SQL, right? The familiar ANSI SQL based Transact SQL standards. It's fully built upon that. And the strength of SQL tooling, Management Studio, Data Studio, any kinds of SQL tools you're known to, you're used to, you can use to connect to the data warehouse. AI. So, but one problem, one challenge you get with this traditional SQL Server or even in SQL Azure, SQL DB, is that administration, right? It's very mundane, very complex. The AI integration takes a lot of that headache out of your hands. As an admin, you don't need to worry about maintaining your tables, maintaining your workloads, fine-tuning queries. I'm actually, if you stick around, I'll show you actually a cool demo. Bob kind of stole my thunder with the Copilot integration demo, but I have some more than what he showed. So stick around, I'll show you a cool demo. I promise you that you will like it, okay? So this is the engine. So again, massively parallel processing with the AI integration, infinite serverless compute, and with all backed up by the open storage format of Delta Parquet is what you get with the Fabric Data Warehouse engine. Feel free to stop me anytime if you have any questions. But yeah, or you can also wait until then, and so I'll be sticking around for some more time. All right, so let's go a little bit more detail into what are the capabilities available with Fabric Warehouse. Simplified developer experience. So like I said, it is no provisioning required. You don't need to the entire Fabric is based on this 5x5 model. It's like 5 seconds to what is that thing called? 5 seconds to deploy and 5 seconds. There's something about that. What is that?
Impress.
Say again?
Impress.
Impress. Yeah, 5 seconds to impress and 5 seconds to deploy. So that's the same thing in the warehouse. You don't have to provision anything. You just, I'll show you in the demo also, like how quickly you can actually start working with creating a data warehouse and using it. And like I said, T-SQL language support, intuitive UI. You saw Bob showed the web-based, Fabric UI. So it's all based on that. So you can write your code, you can develop your query, your workloads, your Copilot. Everything is available with the intuitive web interface. And the Copilot for productivity. And like I said, one copy, one lake. So you have the data in one place, in one lake, and then that you can use, that will be exposed as tables, what you're used to in a traditional SQL Server. So you can connect to your tables, manipulate the data from tables, but all that is happening behind the scenes in the, where?
One lake.
One lake. Thank you. I just want to make sure you guys are paying attention. So I'll be asking questions here. So yeah, so it's all backed by that one lake, one copy of the data in Delta Parquet format. But it doesn't mean that because the data is sitting in one lake, you can go and directly manipulate the data. Then that is defeating the purpose of the entire database and where is the security, right? So the data is sitting in one lake, but the only way you can manipulate, the only way you can access that and update is through the interface, the SQL interface. So you get the best of both worlds. You get the SQL front end to be able to use for manipulating the data, but you also get the back end of Delta Parquet capabilities with all in one place, right? Data is reordered. So this is, think about like, yes, for those of you, if you're familiar with SQL, Spark, Parquet, you probably know, so it's like an optimization technique, which is proven to give more than 16% improvement in performance with the reordering. So that is also built into it to give you better performance for your tables. Fully serverless, I keep repeating, but this is something that you should know. There are no physical resources are not only assigned when the query starts running, right? Within milliseconds of the time. And the size of the compute that's going to be allocated is based on what are the requirements for your workload. So there is nothing that you're reserved, there is nothing that you're hit by limits of your compute, your hardware, none of that, because it's infinite serverless compute that's available. Instant scaling up and down, so based on the requirements, the capacity, the compute capacity will scale up and down, which gives you the best performance, price versus performance sweet spot for you executing your analytical workloads. Easy for users to analyze, so you can share the data because again, being that intuitive web interface, you can easily share your data, you can set up access, everything with a click of few buttons to be able to share and collaborate the data with anybody that you're working with, right? Auto integrate with Power BI, either direct link model or import or direct query, so it automatically integrates. So you can use the warehouse as a backend for your Power BI front end, which can run the queries against your data warehouse and build reports for you and give it to you in a quick and timely manner. Easy for data scientists, like I said, yeah. So if you're more familiar with your notebook experience, say Spark. How many of you familiar with Spark? How many Spark gurus here? That's it? Only 3, 4? Okay. Yeah, so if you are more familiar with Spark, you are more, want to use notebooks, although I don't know why you want to use it. I'm a SQL guy, I'm not a Spark. But yeah, so if you are familiar with that, so yes, you can build models using your data warehouse data, using your Spark notebooks, because there is tight integration into it, right? Enterprise-ready platforms, all the data security features of what you cannot call your a service enterprise-ready if you don't have state-of-the-art security features, right? So that's the thing. So you have object-level security, where you can actually pick and choose your objects, like what level of security you want to give. Because again, the data is sitting in the Parquet, but is exposed through metadata as tables. So you can treat them as any other regular tables, like you can specify your table level, object level security, column level security, row level security, or even dynamic data masking. So all these you're probably familiar with on the SQL Server side. So those are all built into it to provide that enterprise level security features. Performance monitoring, obviously, yeah, so we say it is built, self-monitoring and everything, but we do want to give you some knobs to look at, like, if things go wrong, and they can, in order to look at that, in order to see what's going on behind the scenes, we provide query insights, dynamic management views, the best monitoring experience. Again, that makes it enterprise ready, right? Lineage, sensitivity labels. I briefly mentioned about Purview, right? So using Purview, you can assign sensitivity labels to your data, categorize your sensitivity out of the data, and manage and handle that data appropriately based on those sensitivity labels. So all that is built into that. and AI. So you already heard a lot about AI. So yeah, best out of the box query performance. So self resilience, self managed performance. You don't need to tweak a lot of knobs and buttons in order to get the performance. It is giving you performance out of the box, and the AI integration is helping to make that even better. As it learns about the workload, it can actually make it better, so you don't have to use your mind, you don't have to use your brain cells to get tweak and tune the performance of your DW workloads. Okay, so medallion architecture. How many of you know about medallion architecture? Oh, good. Okay, so it's basically, so in any analytical or even traditional database-based architectures, you talk about medallion architecture, which is like a layered approach of silver, bronze, gold. And recently, even I saw platinum. Any of you seen platinum layer? Okay, so yes, it's basically how the data, so as you see here, like for example, raw layer can be bronze, like you're pulling the data into bronze, and then you transform that into a silver to make it even, make it more performant, and then gold at the end for serving layer. So the data warehouse can be integrated into your medallion architecture. How? So let's walk through this architecture. So data sources, it can be any of your data sources, be it semi-structured or structured data sources, CSVs, your SQL server databases, tables, your JSON, all these, structured or semi-structured, like, data coming from some signals, like some signals coming from some industry sensors, for example. So all that can be ingested, and for ingestion, we have Fabric pipelines. How many of ADF, Data Factory? Anybody familiar with Data Factory? Yeah, good. So Data Factory, we call it Fabric pipelines in Fabric. So you can use Fabric pipelines, and you probably know, a lot of sources are supported with Fabric pipelines. So using pipelines, you can ingest the data into your raw layer, which could be on an ADLS Gen 2, like a traditional Azure storage, or it could be on OneLake in Fabric, right? So, and then this box, sorry, I don't have the pointer. So the warehouse, this is where the integration of that medallion architecture, where you can build your silver and gold layers in data warehouse, and then you can do the transformation using, guess what? The traditional stored procedures, right? So people who are familiar with SQL Server know the advantage and capabilities of stored procedures. So you can use stored procedures, that you're familiar with stored procedures, to build your transformation code, which can be used to transform the data between silver and gold layers. It could be ELT, extract, load, transform, like load and then do transform, or ETL, extract, transform, and load, right? Regardless of whichever it is, you can use stored procedures with it, because warehouse supports stored procedures, and you can use stored procedures to transform the data. And then once the data lands in silver and gold, you can, because of the integration of warehouse with a lot of reporting platforms and applications, so you can use your familiar Power BI reporting, or traditional query tools like Management Studio, or even the web interface for warehouse, or even custom apps or data science notebook. So all that can be used. So this is how you can build the medallion architecture using, and this is, I'm not saying that this is the only way, this is one of the ways, right? The opportunities, the options are endless. Like you can build the traditional, your architecture based on your needs, but warehouse can be an integral part of that architecture because it can integrate with your existing existing data sources or applications and reporting platforms. All right. So, okay, when to choose my Fabric warehouse, right? So this is the question I get a lot of times, because even today somebody was asking me, like, warehouse or lakehouse, right? So I think we kind of made that a little bit confusing, to be honest. So when to use warehouse versus lakehouse, because we say, in Fabric, you can bring all of your data into a lakehouse, and then use your Spark or SQL Analytics endpoint to consume the data. Yes, it's possible. Yes, it's doable. Bob also mentioned about that, like where you can mirror the data from SQL DB into Lakehouse and use a SQL endpoint on that. Yes, but if you want a highly performant, analytical platform, you may want to use warehouse. Lakehouse alone may not be sufficient. And I'm not saying that it's either a lakehouse or a warehouse. It could be sometimes a combination of those. Some data can sit like in the medallion architecture we are looking at. For example, the raw layer can be a lakehouse. Bronze can be a lakehouse. Silver can be a lakehouse. But gold can be a warehouse, right? So let's see where to. I'll try to minimize some of the confusion of when to use warehouse or lakehouse by showing like when warehouse would be an appropriate fit. Your primary in-house development is and administration skills are in SQL. So if you're more of a SQL guy, not a Spark, and if your primary development, which is most of the traditional shops, right? SQL analytical shops, not just SQL shop. So most of the time, the SQL is your choice of development language. If that is the case, warehouse would be a good choice because again, like I said, it's based on the age-old transact SQL language, right? But if you had to change that into a lakehouse, now you had to convert all of that into Spark, which is going to be a costly affair. And you're all your Spark SQL gurus need to now turn into Spark. There's a lot of learning curve. So yes, if it is a traditional SQL shop, warehouse is a great choice for you, right? And you already have logic written in SQL stored procedures. If you're a SQL shop, you have SQL stored procedures. Now you don't want to go start because Spark doesn't support stored procedures, so now you have to rewrite them if you want to go into a Spark-based model, right? So if it is, if you are using a lot of stored procedures, T-SQL core, warehouse would be a good choice for you, right? Multi-table transactions, that's another thing. So you can actually, within your stored procedure or within your SQL core, you can have transactions across multiple tables so they can all work together. So if that is the case, warehouse would be a good choice as well because Spark doesn't support multi-table transactions as far as I know. Last time I checked. Yeah. SQL tooling ecosystem. So if you're using SST, if you're using DBT, if you're using SSIS, Informatica, these are all SQL-based tools. Click, Tableau, then also warehouse would be a good choice for you. And if you invest into a complex data security using SQL security models like OLS, object level security, column level security, row level security, if you already invested into that, your entire security model is based upon this SQL security layer, warehouse is a great choice for you because then again, rewriting all that is clear file, right? If you're migrating from an existing SQL sources, on-prem SQL Server data warehouses, PDW, APS. Anybody know APS? No? Analytical Platform System. Thank you. So if you're migrating from any of those, or even our Synapse dedicated SQL pool, well, guess what? The easiest, fastest path is going into warehouse. So I have seen some customers trying to learn the hard way by taking their Synapse dedicated pool sources and migrating into a Spark-based platform and realized that they did a bad thing and they had to go back again. So please do not be those guys, right? So it's a shortest, fastest migration path. In fact, I'll show you a demo of that as well. And mostly structured, semi-structured data. There is also, because it gives best price performance option. Okay, so let's look at a little bit more about this self-management. So this is how, again, going a little bit more into life cycle of a query. Let's say you create a data warehouse and you submit a query request, select from so and so. What happens? There is a SQL front end behind the scenes that is again based on the familiar SQL platform. So that takes your query and then SQL optimizer, it will do its optimization and send the control to DQP, distributed query processing. That's where your query will be broken into multiple tasks. Okay, so you submit a query, and that will need to be now executed. That execution happens through DQP, which breaks this SQL query into multiple tasks and hand it over to the SQL pool. SQL pool is nothing but those compute I was talking about. So it is not something that will be available at the time of you creating the warehouse, but as you submit the queries, we will make sure that we will create a compute pool called SQL pool with the number of nodes needed based on the query estimation, right? So as you notice, there are two different pools. This is again different for those of you who are familiar with Synapse. Everything is using the same compute pool. There is always conflict. So if you're loading data, at the same time you're trying to query, the same compute will be used for both, which is causing a lot of conflicts. But here, we made it better by using separate compute pools, by using a separate pool for non-selects, like your ETL loads. If you're ingesting the data, so we will give that to a pool that is optimized for loads, right? Because the compute that's used for loads versus the compute used for selects, optimization is going to be different, right? So that's why we have separate set of nodes, and if the data is mostly loads, we will send it to the non-select SQL pool. If they are queries, they will go to the select SQL pool. So that's the job of the DQP to take care of that, and then eventually, obviously, the data is sitting in the one lake in the Delta Parquet, exposed through metadata like the tables and rows, like what you see here. So this is the metadata layer, which is actually nothing but exposing the data through the metadata to your SQL pool. So that's how. So we will execute, and then once the data execution happens, the results will go back to the SQL front end. So all this happens in the middle. The one thing to understand, burstable capacity. So this is different again from Synapse. So I said we will assign the compute based on your query requirements, right? But there is also a capacity. Bob was talking about F capacities, right? F32, F64, F128. So these are the capacity is available with Fabric. So there is a limit on the amount of compute that can be used by capacity, obviously, right? Because higher the capacity, it's going to be more expensive, so we need to give you more compute power. But what we do here is something called bursting, which means, imagine this, like, so you're buying $1 million home, but do you need to spend $1 million now to enjoy the home? No, right? So you take mortgage. I know the mortgage rates are so high these days, but anyway, but yeah, so you take a mortgage, but you get to enjoy the house without even paying the full price. Same thing here. So the bursting, so when the query requirement, when the DQP sees, let's say based on your compute capacity you purchased, we can only give you 10 nodes, right? But we don't stop at 10 nodes. If the query requires more than 10, we burst. So we use more than what you paid for. So that way, what happens is, like, the query can get executed even faster. It's not bound by the compute power you purchased. But then how do we recoup the cost, right? So because it's not going to be always, your query load patterns or workload is not going to be all the time at 100%, right? You have ups and downs, right? So we kind of even that out. So when the query peaked, during the peak time, when the query you need better performance, we give you more compute, and when there is an ideal time, we try to even that out, like we take back the compute you used, more than what you paid for. So that way we kind of even that out. So that way you don't have to worry about scaling up, scaling down, getting more compute, reducing when it's not used, because we do that for you. That's the whole point of SaaS platform, right? If you're not able to do that, then why should we call it as a software as a service? So we want to take those headaches of managing your compute, bringing the tuning the knobs to get better performance, We take it all out of your hands by doing these kind of magic tricks behind the scenes, bursting, smoothing. So maybe it's a, I mean, there is a lot to cover in that, but I know I'm almost out of time, so that's why I'll go quick. So, but yeah, this is what happens. Distributed query processing, elastic, resilient, DAG. For those of you who are familiar with Spark knows DAG. What is it? Direct Acyclic Graph, I think it's called. Yeah. So we process the task. I told you, query is broken into tasks. So the task are executed in parallel, so you get even better performance. All right. So let me. I told you, I promised you I'll be showing you a cool demo. So let me show you the demo about how the Copilot integration happens in Warehouse to give you better developer experience. I hope the audio works here. Maybe I need to. It's 100%. Do you need to increase it in speed?
How easy it is to build a warehouse schema, ingest some data, and start querying said data within a matter of minutes, all using Copilot. Let's dive right in. To start, I'm in the warehouse editor. My warehouse is currently empty, as you can see, with no tables or objects currently present. I see a Copilot button in the ribbon. Let's see if it can help me out. I asked it to create me a table called geography, and I specify some column names. In just a second, Copilot was able to return me a SQL query to create a table called geography. Let's insert it into my query tab. As you can see, Copilot not only gave me T-SQL code, but it also gave me a step-by-step plan on how it came up with it too, helping me understand its thought process. Let's run the query. Now that the query is finished running, I can see that a table called geography has been created in my warehouse, and it even has the...
Notice that, like, I just asked Copilot to create the query, didn't give any information about the data types or anything, but it came up with some, estimated data types based on, for state, I don't know why it used weight category though, but anyway.
Thank you.
But for zip code, it used WinCat 10, so it came up with, decent estimated data types.
The column names that I specified, without having to write a single line of code, all thanks to Copilot. I repeat the process, and I get a Copilot-generated script for the rest of the tables that I want to create. I run the script, and now the rest of my schema has been created. So I'm ready to start ingesting data. But how? Let's ask Copilot. I simply ask Copilot how to ingest data into the warehouse, and it tells me all the different options I have. I see that copy into is one of the supported ingestion methods, and I want to use it. Let's see if Copilot can help. I open a new query tab and start to write a comment in my query editor, asking Copilot to generate a copy into script. I provide a generalized blob storage endpoint that it needs to pick up from, and it automatically recognizes the table name variable and creates copy into scripts for each and every one of my tables. I decide to accept the Copilot suggestion with a quick tab, and I run the script. And ta-da! All of my tables are now populated with data. Now that my data is ready, it's time to start querying it to uncover some insights. But I'm not even sure where to start. Let's ask Copilot. I see a suggestion from Copilot to find some cool trends in my data. I decide to click the prompt and see what it comes up with. In just a second, Copilot suggests me different data points and trends to start analyzing. I notice that the topic it suggests to me are personalized to the schema of my warehouse. I select a topic that I'm interested in, and I decide to ask it that question. I click Ask, and within just a couple of seconds, Copilot generates a SQL query for me. I simply insert this query into my query editor, and I can run it. Now, I am able to see all the average trip distances per each city. Now, I want to write some queries of my own to start analyzing my data further. I write the query to retrieve the highest temperature per each city. I try to run it, but I'm met with an error. I can't figure out how to fix it, but I see an option to fix my query errors using Copilot. I click this button, and Copilot automatically fixes my query. I try to run it now, and my query works perfectly. I
I used to be a developer, and I was like, where was all this when they used to write my queries? Like I used to spend days identifying problems and to write the right code. Like, yeah, I missed all this. Anyway.
Switch to another query that I have written. To make the query reusable for others, I want to leave comments in my code, but it takes up too much of my time. I see an option to explain my query using Copilot, so I click it. And Copilot automatically leaves inline code comments throughout my code so that others can pick up right where I left off. This is just scratching the surface of what is possible with Copilot. In this demo, I showed how you can use Copilot to create a warehouse schema, ingest data, query that data, and even explain and fix my handmade queries. Copilot is a SQL developer's best friend and will transform the way you work with data warehouses.
All right, so I think I'll stop here, although I'll show one slide where, where how you can join the party. Like this, I want to show you, of course, this slides will be shared with everyone, right? So, yeah, so there are some useful links here. There's useful links to the roadmap of what's coming up. Again, like what Bob mentioned, we are making changes, improvements on a weekly basis, not even monthly basis. Every week, you will see a new feature coming. So Fabric roadmap is a right place to go, and these are all your places where you can get a lot of information about, connect with the different people who are using Fabric, post your questions, get answers. So please, I invite you to go through these links where we will share the deck, and you can get all these links at the time. All right? Thank you. I'll be sticking around for some time. If you have any questions, please come in.
Can I ask you one question?
Yes.
Okay. What role OneLake play in centralizing and securing data across the multiple workloads?
What role OneLake plays?
Centralized and securing data across the multiple workloads.
So like I mentioned, for the purpose of in case of warehouse, the security happens at the warehouse layer. Although the data is sitting in OneLake, but the security is provided because you cannot directly access the data in OneLake. You are securing your object level security, column level security in the warehouse. Similarly, other services have their own way of securing the data that is sitting in OneLake. Is like one place where all your data is sitting, but you can use these different services to secure the data that is sitting in
This goes to the centralized process.
Centralized? Well, there is also like a OneLake level, so catch me up in there, so we'll talk more about that.